Good evening, everyone. ICSI is back with our Jal Sarakshan water webinar series. And you can see that this is Friday and we are here. Usually we come on Saturdays. But from today, a very pious day, that is Guru Purnima, we want that because this particular cause need guidance. This needs kind of a backups and advice of all intellectual brains and all those guide us that we should start from this particular pious occasion, that is Guru Purnima. We should start this webinar series once again on every Friday at 5 p.m. तो आप सब दर्शकों को जो हमें आज YouTube पे के जरिए लाइव देख रहे हैं, उन सबको ये मैं बताना चाहूंगी कि आज से दोबारा से हम ये सीरीज फ्राइडे शुक्रवार के दिन आप सबके लिए लेके आ रहे हैं 5 बजे। अब एक चीज और मैं आपको स्क्रीन पे बताना चाहूंगी। मैंने एक तरफ कोट लिखा है कि जल का कोई रंग नहीं, ना ही इसका स्वाद, जल जीवन का सार है, बात रखो ये याद। हमारे पुराने गुरुजन, हमारे ऋषि मुनि, जल एक ऐसी महत्वपूर्ण चीज है हमारे जीवन में, और ये आज की बात नहीं है, ये सदियों से हम सुनते आए हैं। और कितना ही कोई भी पावन पर्व जब भी होता था, कोई पावन कार्य होता था, तो सबसे पहले जल लेके हाथों में और जल के जरिए हमारे जितने भी ऋषि मुनि हैं वो इस सारी क्रियाओं को करते थे। तो उस समय ये कहा जाता था कि जल का कोई रंग नहीं, ना ही इसका कोई स्वाद, और जल ही जीवन का सार है, बात रखो ये याद। पर आज हमारा जो टॉपिक है, आप देखिए 21वीं शताब्दी में जब हम इतना आगे बढ़ चुके हैं, तो हमने उस पवित्र जल को इतना दूषित कर दिया है कि आज के साइंटिस्ट, आज के जो बुद्धिजीवी हैं, वो ये भी एक रिसर्च का विषय बन चुका है कि वाटर का भी कलर है। वैसे तो वाटर का कलर अलग अलग रीजन से होता है, वो सब हम जानते हैं जो इस फील्ड में एजुकेटेड हैं, उनको पता है। देयर कैन बी अ ग्रीन वाटर, देयर कैन बी अ क्लियर वाटर, देयर कैन बी अ डार्क वाटर। सो बट आज का जो हमारा टॉपिक है वो हमने रखा है रीयूज ऑफ ग्रे वाटर। इतना दूषित क्यों, इतना हमने प्रदूषण क्रिएट कर दिया है कि आज हमें कहना पड़ा है कि ग्रे वाटर भी है उस प्रदूषण के कारण। एंड आज का जो विषय हमने चुना है वो यही है कि हाउ टू रीयूज ऑफ ग्रे वाटर टू सस्टेन द वाटर डिमांड। आज के दर्शक जो हमारे ये प्रोग्राम देख रहे हैं, मेरा उन सब से यही अनुरोध है कि प्लीज 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 इस महत्वपूर्ण जीवन के एक महत्वपूर्ण अंग जो हमारा जल है, जिसे हम पानी भी कहते हैं हमारी आम बोलचाल की भाषा में, इसका सदुपयोग कीजिए, इसके महत्व को समझिए, इसके महत्व को पहचानिए और इसका इतना अच्छा संरक्षण कीजिए कि आगे आने वाली पीढ़ियों को फिर से वो जो शब्द था कि जल का कोई रंग नहीं, ना ही इसका स्वाद, तो वो चीज वो लोग समझ सके। नहीं तो ये जो दोहे हैं, जो हमारे पुराना पद्धति चली आ रही है, ये सिर्फ हमारे किताबों में और किस्सों में बन के रह जाएंगे, और आगे आने वाली पीढ़ी भी जो देखेगी वो यही देखेगी कि वाटर इज एक्चुअली colorful and because of pollution, because of pollutants and other things. So without wasting any time, I would like to straight move forward. I would like to tell that आज के इस टॉपिक को प्रेजेंट करने के लिए हमारे साथ जो गेस्ट हमारे साथ जुड़े हैं, प्रोफेसर केडी यादव जी। ही इज एसोसिएट प्रोफेसर डिपार्टमेंट ऑफ सिविल इंजीनियरिंग, एसवी नेशनल इंस्टीट्यूट ऑफ टेक्नोलॉजी, सूरत, गुजरात से। और इनके साथ बातचीत करेंगे जो हमारे सेशन चेयर हैं, हमारे चीफ एडवाइजर सर हैं, जो सिंगापुर से हर हफ्ते हमारे साथ जुड़ते हैं और हमें बहुत अच्छे अच्छे सजेशंस वाटर मैनेजमेंट एंड वाटर कंजर्वेशन के लिए देते हैं, श्री अनिल मनोचा सर। दोनों अतिथि गणों को आप सबके सामने लाने से पहले मैं कुछ स्लाइड्स दिखाना चाहूंगी। आज इस विशेष पर्व पे हमने कुछ कार्यक्रम आप सबके लिए रखे हैं। वो कार्यक्रम क्या है, किस समय पे आप आए यूट्यूब पे, आप सब एक बार हमारे साथ ये देखिए, और उसके बाद अनिल मनोचा सर और प्रोफेसर केडी यादव जी के साथ हम इस चर्चा को आगे बढ़ाएंगे। हमारी स्लाइड ICSI की, और हम सब साथ मिलके काम कर रहे हैं, और चाहे वो वाटर वाटर कंजर्वेशन हो, एजुकेशन एम्पावरमेंट हो, सब कुछ हमारा अंडर द वन अम्ब्रेला है, मेकिंग एजुकेशन रेलिवेंट। आइए शिक्षा को प्रासंगिक बनाएं और आप ये जो स्लाइड देख रहे हैं ये हमारे वेबिनार्स हैं जो आज स्पेशल डे पे हम सब ने ऑर्गेनाइज किए हैं। सुबह आप सबने 12 बजे हमारे साथ देखा, स्पेशल केयरिंग चाइल्ड पे एक प्रोग्राम था, शिक्षा कौशलता उद्यमिता। जिनसे वो छूट गया है वो दोबारा हमारे यूट्यूब चैनल पे जाकर जीएस मोटिवेटर पे वो प्रोग्राम देख सकते हैं। अभी हमारे साथ है वाटर मैनेजमेंट की सीरीज, और उसके बाद आप एक स्पेशल प्रोग्राम हमारे साथ देखेंगे गुरु पूर्णिमा सेलिब्रेशंस पे ही। और उसके बाद जो हमारी एक सीरीज हमने आज स्टार्ट करी है वो 8 बजे है और 9:30 बजे है। आप सबको बिना मतलब ज्यादा बोलते हुए मैं एक बार वो स्लाइड से दिखा देती हूँ ताकि आप खुद समझ सके। सो वाटर कंजर्वेशन इज ऑलवेज being a very important and most relevant part of education, and it should be incorporated at all levels of the education system. आज 6 बजे ये प्रोग्राम है जिसकी मैं बात कर रही थी, और 8 बजे जो हमारी इस हफ्ते पूरी हमने सीरीज स्टार्ट करी हुई है फ्रॉम मंडे, एनईपी 2020 आर्ट इंटीग्रेशन इन एजुकेशन, उसी की कड़ी में आज का 5वां भाग है इसका, और आप जरूर देखिएगा 8 बजे ये। और इसके बाद 9:30 बजे स्पेशली हमारे साथ प्रोफेसर विवेक शंकर नटराजन जी आज के खास दिवस पे जुड़ेंगे, और गुरु पूर्णिमा पे उनकी क्या राय है, उनकी तरफ से एक विश्व गुरु जो भारत है उसके बारे में अपनी विशेष राय वो रखेंगे इस प्रोग्राम में। 9:30 बजे आप सब हमारे साथ जुड़िए। एंड व्हाट्सएवर ह्यूमन माइंड कैन कंसीव एंड बिलीव कैन अचीव, लेट अस कम टुगेदर फॉर मेकिंग एजुकेशन रेलेवेंट। आप अपने सजेशंस भेजते रहिए क्योंकि उसी के जरिए हम अपने प्रोग्राम्स को एम्पावर करते हैं। और आप सबके सामने ईमेल आईडी यहाँ पे लिखी हुई है, जिस ईमेल आईडी पे आपने अपने सजेशंस, अपने अच्छे अच्छे विचार, अपने हमारे प्रति प्रोत्साहित भरे हुए शब्द लिख के जरूर भेजने हैं। और इसी के साथ में दोबारा से ये स्लाइड पे आई और मैंने स्टॉक शेयर किया है, और अनिल मनोचा सर का और प्रोफेसर केडी यादव सर का बहुत बहुत धन्यवाद कि वो आज हमारे इस प्रोग्राम में आए हैं। एंड आई वेलकम बोथ ऑफ देम, एंड नाउ आई हैंड ओवर टू श्री अनिल मनोचा सर to further move with the program. Good evening, sir.
Yeah. Good day, everybody. Today we are holding 42nd webinar on water series, which we started from 23rd July, 23rd October 2020. If you revisit what we did, we discussed various subjects, in the water series. We talked about water issues related to various countries. We talked about how inter-boundary disputes took place. We talked about water in Mekong River Delta. We also spoken about how the upstream construction of dams has affected the agriculture crop in Laos, Vietnam, and other parts of the world. We have spoken about the success stories of Singapore, how Singapore, being a country where even the water is imported, has been able to effectively bring technologies and bring innovations in the water field. We spoke about how the South Africa, Cape Town water crisis was managed. And we also have spoken about the water education. We spoke about water as a carrier. And while we talked about water as a carrier, we also made our participants and audiences aware that water is a recession-proof carrier. We talked about various water sources. We talked about water issues. We talked about water education. And in this series, we were associated with various speakers from various parts of the world. We had speakers from US, we had speakers from UK, we had speakers from Singapore, Malaysia, and nevertheless, a lot of people volunteered from India, whether they were professors, they were the water warriors, they were social workers. They got connected with us and gave their mind to us. Now, while we will be able to see all those previous webinars in our GST motivator, and before I give the floor to Professor Yadav, I would like you to think 2-3 things. We are in a situation of COVID pandemic. Now, in this situation, the world still 1/3 of the people, 2.3 billion people, don't have access to water, even to wash their hands. We also lack the proper sanitation system. In India, only 25% of sewage is treated. We consume more, whatever water we consume at our homes, 65% of water comes as gray water. Uh, Whatever water we consume at our homes, about 20% of water comes from the sewage. So 65 plus 20 is close to 85% of water. This 85% of water has a large scope of recycling. And we today, when we are looking at the water scarcity issues, we are also have been enlightened that we do not have water shortage as an issue, we have water management as an issue. And every time, whenever we speak, we bring speakers who talk about those issues, who talk about those concerns, and who bring their knowledge to us. And to in this particular effort, today we have Professor K.D. Yadav, who is from who is associate professor with SVNIT Surat. Dr. Yadav holds a PhD degree in environmental engineering from IIT Kanpur, and he has been teaching in the university for more than 13 years. And while teaching various postgraduate students and PhD holders, he has been associated greatly in providing consultancy services in the area of solid waste management, liquid waste management, providing ecological sanitation solution and composting. He has published a series of research papers in national and international journals. And with his knowledge in this particular field and with the experience he has, I think all of us will get benefited by his contribution in the water. With this small background, I will request Professor Yadav to take the floor and give us deliberations. Over to you, Professor Yadav, please. Thank you.
Okay, thank you very much, Anil Sahab, MANOCHA ji, Chitra ji, Dr. Gulshan. We have a certain network issues here, so I will not use the video because here in my institute, Zoom is not working properly. So excuse me. I will prefer to talk it's a mix, Hindi or English. I think it's because audience is diversified. And this is the purpose of the presentation here, what we can do with the gray water. And before starting that, I would like to say something. I will give you what we are doing exactly here. So introduction is already given by Mr. Anil, because I am here is a teaching faculty, and as well as we are deeply involved in the gray water consultancy work. So we are not only the running the experiment in the laboratory scales, we are developing the model in the laboratory, and then further we are implementing those models first at pilot scale in SVNIT Surat, and then further into the society. So here I will give you some brief what we did in the laboratories, what individual can do. So here my presentation is more focused on how we can have a small reactors, or we can have a setup so we can treat the gray water and we can reuse this gray water for the different applications depending upon the requirement. And along with this, other area of working is I'm working in flower waste management, and we have developed the very good technology how to convert the flower waste into the nutrient-rich compost. The reason being because the major problem with the flower, it's a very good, it's a value till it is in your hand, and once you offer to someone, it becomes a waste. Only the flower is one of the, we can say, the things which is within a second converting into the waste. We all know if you offer to the God or offer to the any minister or of our relatives, whatever, till in our hand and hand over, and it is a waste. And why we have considered, because we have a lot of, we can say, Asian countries, specifically myth or whatever, हम फूल को फेंक नहीं सकते, and we always throw fool into the river or any water bodies. And now you can imagine, जब पिछले जमाने में, अब पिछला जमाना बोल सकते, जब फूल पानी में फेंके जाते थे तो पानी के अंदर करंट होता था, and current will take care about that path and other thing, then it is not problem. Nowadays, due to the construction of the dams, due to the limitation of the water, all bodies are the stagnant body, more or less. And if you will throw the flower into the stagnant, there is a deterioration in the quality of the water. So with that motto, we developed a lot of techniques, and I'm happy to share we got a 6th patent on this development of the technology for flower waste to compost. And now, so we are focusing on only on 2 areas, grey water and to the flower waste. So with this, I would like to share some screen. And before that, I think we all are aware about what is the grey water, even though if our, I think this slide is visible.
Professor, yes, it's visible.
Okay, so it is more about, I will give the what is the grey water we have. So grey water is a nothing but a, why we'll call it a grey water, because we have a concept of the black water, grey water, and yellow water. Yellow water is nothing but a urine, whatever we will discard. Black water is which is coming from the toilet. And over the period when the H2S production is there, the color of the water becomes a black. That's why we call it a black water. And remaining is the grey water. Whatever the type of the activities we have, either we'll call the activities, any other activities. So this is the, if you say the general picture of the, we can see the grey water, how the grey water is coming, what kind of the systems we can adopt it, how we can use that grey water. So this is the general scenario specifically into the Indian conditions, let's say. So, and this is the sum of the activities is shown here. Either we are cleaning our clothes in a dishwasher, in a utensils in a dishwasher, or in a washing machine, or into the sink. So these are the certain activities. So if you will do any kind of the activity other than the toilet, then all the water is called as a grey water. And I tell you certain fact about the grey water. If you see the last line is written here, grey water takes the 55 to 75% contribution in domestic wastewater generation. Means after the use, when water is used, then it will convert into the domestic wastewater. And if I say the what is the contribution of the grey water, so it varies from 50 to 75%, depend upon the uses and other thing. And remaining is the is your black water basically. And other thing is important here, whatever the water we have, that's the further can be divided. Grey water, I can say the dark and the light. Light, if I simply say while we are washing our hands, for example, in a wash basin or in a bathroom, we are taking the bath. So we call, where is the load is low, we will call it a light. And whenever the load is high, for example, the washing machine and the dishwasher, where the quantity of water is used in a lower concentration to clean the larger mass. So we'll call it say dark grey water. So this is can be targeted depending upon the how much water we are producing. The technology is for treatment purpose. This is the light and grey water is the important. So if I say here, further I will talk about only the grey water. So if you can say kitchen and sink is 27%, laundry and washing is the 26%, and remaining is the 50%. So 50% water is almost have a very low labor load in the grey water itself. The load is not very high. So this can be easily targeted for the treatment purpose, even though if you are mixing, that is not an issue, except kitchen. Because the problem with the kitchen, whatever the grey water is coming, that grey water have a lot of oil content. Sometimes it's a food particle also while we are cleaning the utensils. So there oil and grease and the food particles are certain times is issue. So that may be discarded if because their concentration is not very high. So that's why we are treating, which I don't want to go in that details, because we all know nowadays we are facing a lot of problem related to the availability of the fresh water. Fresh water is not available. There are number of regions, and the first region we can say only because we are slowly get rid of the conservations. अगर आप पुराने इंडियन कस्टम या एशियन कस्टम्स को देखिए, whatever राजा महाराजा या जो भी हुए हैं, सबने एक पानी के संरक्षण के लिए तालाब बनवाते थे, कुएं बनाते थे, बावड़ी बनाते थे। आई थिंक वो ओवर द पीरियड खत्म होती जा रही। मैंने अपनी आंखों के सामने आज तक कोई कुआं बनता नहीं देखा है। कभी कभी किसी गांव में जो एग्जिस्टिंग तालाब है उनका थोड़ा रिनोवेशन किया गया है। ऑन द कॉन्ट्रेरी हमारा कंजम्पशन ऑफ वाटर सिग्निफिकेंटली इंक्रीज हो गया। एक साइड हमारा कंजर्वेशन बिल्कुल पुअर होता जा रहा है, दूसरी तरफ हमारा वाटर की जो कंजम्पशन से वो इंक्रीज होती जा रही है। सो व्हाट वी कैन डू? सो इन दिस केस क्वेश्चन कम्स, जो भी वाटर हम यूज कर रहे हैं एटलीस्ट उसको थ्रो करने से पहले whatever we can reuse, we should reuse, and that's the concept of the gray water we have here. The reason being very simple, because as I told you, ये इसके अंदर बहुत ज्यादा लोड नहीं होता है, टॉयलेट फ्लशिंग से नहीं आता है, तो इजीली उस वाटर को हम यूज कर सकते हैं फॉर ट्रीटमेंट पर्पस। और कहाँ पर इसका यूज हो सकता है? इफ आई से वेरी सिंपल द थिंग्स, इफ we have a lot of myth in mindset, so we can go for the toilet flushing only, because we all know in the toilet flushing we are using the maximum quantity of the water. I tell you in general, if you go for the in the toilet, if you go for the urination purpose, you imagine the quantity of the urine which we are discharging into the toilet is 400 to 500, approximately 500 ml. And while we are flushing that, even though if it is a low flush, I can say, forget about the entire quantity. And mostly, if I say, rarely we have in a flush tank major and minor compartment. But even though if you have a, for example, 8 liter and 3 liter is minor and 5 liter is the major, you imagine in a 500 ml of urine, we are using the 300 liter, 3 liter to the 8 liter of water. So toilet flushing can be easily targeted. Gardening can be used. It can be used for the groundwater recharge, firefighting, floor cleaning. These are the things. For example, certain things are easily acceptable, certain things are not easily acceptable. So these are the some technicals, so I will skip it here. And there are the guidelines are used. For example, the guide, we have all over the world, or specifically Indian conditions. The major solids, go into the details further, and then disinfect it and use it depending upon the what kind of the application. So these are the techniques which is in general used for the grey water treatment purpose. That may be constructed wetland, maybe filtration, maybe RBC, MBR, SBR. This is the overall, either it is a small level or it is a bigger level, we can say. So these are the certain photographs. आप लोगों ने भी बहुत जगह देखे होंगे. It's constructed wetland which is very common. It's called the constructed because हम इसको खुद से बनाते हैं, खुद से construction करते हैं. That's why it's called the constructed wetland. Otherwise, wetland is very common terminology. All the time, if land is the wet, जहाँ पर moisture होता है, that is called the wetland. And if you simulate those conditions artificially, then we will call the constructed wetland. Why we are looking for this constructed wetland? Because the reason being, the condition which is naturally is not possible, that we can do the artificially, maybe the filtration system by providing some gravel, by growing the some plant, and we can utilize the different kind of the technique at a single place. So that's the constructed wetland, which is common, very we can say very good technology at a household level, or we can say because it has a certain limitation if we are going for the community or if we are going for the larger quantity of the grey water. So this type of the system are very simple. We can use the like a sand, which is commonly easily available, not required very huge infrastructure. We can simply pass on from that filter and we can reuse that water. We can go for this type of the trickling filter. We can go for the membrane bioreactors. we can go for this SBR, this is called the sequencing batch reactors. We can go to the USB.
Professor, we cannot hear you. Cannot hear.
Now I'm audible.
Yes.
Sorry.
No problem.
So here, if you see a very small setup we have created before going into the field, and this is nothing but it's a combination of the simple media, which is called the grit material, or it's a sand, or it's a coarser sand or finer sand, and then we have grown the different type of the plant. The purpose of this growing is the different kind of the plant. Basically, we can go into the series of the treatment. We can go for the individual, depending upon the specific type of the target used, maybe flushing, maybe gardening, maybe the irrigation purpose. And this plant is over the period is growing, and plant is helping in terms of the treatment. And whatever the media which we are using inside that filter, that is working as a filter media. And if I say what is happening at the end, so these are the, if you see this type of the root, and we try to see what is happening actually. So if you see this side in the bottom, this root is growing here, then it is picked up by hand. How this root, whatever we have, that root is helping in terms of the trapping of the different kind of the pollutant. If you see the further,
So, आपकी आवाज प्रोफेसर साहब दोबारा चली गई है, हम सुन नहीं पा रहे हैं.
hello.
आपसे रिक्वेस्ट करूंगी, आप ना इसको स्क्रीन शेयर पे ना लेकर, मतलब वो जो हम करते हैं स्लाइड शेयर पे, आप वैसे ही दिखाइए, क्योंकि जब ऐसे होता है तो आवाज आ रही है, और स्लाइड शेयर पे वो थोड़ा.
Okay, anyway, I'm end of the presentation. I would prefer more on the discussion part. So now I'm audible.
जी सर, अगर हम आपकी ये जो लास्ट 3 स्लाइड्स थी, एक बार इसको आप दोबारा जल्दी से अगर रन थ्रू कर सकें, जो आपने कहा 21st, 22nd and 23rd का सर.
Okay, so this is basically I want to show it here what kind of the role is played by the different type of the plants. If you see, इनके जो root zones होते हैं, एक major role play करते हैं. That's why we are using the different type of the plant along with the media, because sometimes there's a question mark कि plant की क्या जरूरत है, वो तो सिर्फ पानी लेंगे, so वो तो on the contrary नुकसान करेंगे, पानी की quantity को कम करेंगे. So it is not like that. Plants की जो root होती है वो एक major role play करती है treatment के अंदर. And then if I say this is the, I would
प्रोफेसर साहब, शायद कुछ टेक्निकल प्रॉब्लम है, दोबारा हमने आपकी वॉइस नहीं सुन पा रहे हैं.
So I am stopping my presentation. Chitra ji, I'm audible.
हाँ जी, बिल्कुल
Okay,
sir.
okay, fine. So this is the running model in one of the hostel, and the purpose of that one, generally in a household level, we are not generating more than 1,000 liter of the grey water in a day. So if you see here, how much amount of the space required for treatment of the grey water. So if you can say this is the 3/4 200 liter capacity of the drum, and one we have a 1,000 liter capacity of the drum, where the entire day, whatever the water is coming, that water can be collected. And with these systems, we can treat the 1,000 liter of the grey water. And here we did some experiment by targeting the pathogens and other things that can be depending upon the target use. So this much amount of the space is only required to treat the even 1,000 liter of the grey water, and that can be used for the whatever the quality we have received. That quality of water can be used for not only for the toilet flushing or gardening, that can be used for the laundry also. But sometimes people have a myth, so I don't want to go there. So that's the thing I would like to say here. This type of the
सर हमने आपकी आवाज फिर मिस करी है यादव साहब. I think we missed Professor Yadav during last 1 minute of his talk, but in any case, it was quite a informative presentation, and all the audiences will probably learn from there that technologically we have made significant advancements to ensure that we can use and reuse and reuse the water which we use it on a daily basis. So we have been saying in the past also that water is always used, it is not consumed. So water changes one form to another form, and we can recycle the water and use it for other purposes. Most of the audiences should also refresh their knowledge when we said that in UK, the Thames River water is recycled 7 times. And Professor Yadav today has again emphasized that point, that we have technologies of recycling water. At household level, 80%, 70 to 80% of water can be reused. And technically, the water quality could be as good as potable. You can drink that water. It is only human psychological mind that we will not drink this water, but leaving a drinking application aside, probably all the water can be recycled and reused by various technologies. Professor Yadav has shared the various technologies which can be used for recycling water. And dear friends, we should realize that today we are in a situation where we have to look towards creating a social awareness among the people that we need to recycle the water. We need to create an infrastructure to segregate different types of water which we discharge from our homes. We have to ensure that we somehow collect the grey water, we somehow collect the sewage water, and at the places where it is not possible, it is still possible to recycle sewage plus grey water together in a system. And today the classic example is a Chennai city, where the complete city sewage water is recycled to run a refinery. So we have made a lot of advancements in India, and academicians like Professor Yadav are helping us a lot. Thank you, Professor. And I would also say that probably when we look at Indian history, the human civilization was based on rivers. We talk about Hindu water civilization, we talk about Nile river civilization. And when we look at Chola dynasty in India, they started the water kunds, and they started water ponds, they started water, I should say, wells through a community participation. So we have somehow in the process of becoming educated had lost that touch of community participation and left this task to government to be handled by PWDs and the municipal corporations and the people, and we are in that situation. So it's a time where we should create a social awareness, we create a technological interface, we try to see that how we can collect and conserve and recycle this water. And the messages are very clear that India is capable of addressing the problem, and India is capable of leading the world towards various water recycling solutions through academia, through professors, through water warriors, and through tech industries who are working in the water field. Again, to the education sector people, to students, I will say that water is a recession-proof carrier. So there is no substitute to water. Humankind is still have to find a substitute to water. We could have found various substitutes. We talk about artificial intelligence. We talk about a normal photo getting changed by the e-photos and all those things, but there's still no substitute to water. So with this, I would like to end my submission and probably request Chitra ji or Dr. Gulshan, he is there to sum up and take this presentation to closer. Thank you.
Yeah,
Thank you so much.
Chitra ji, I would like to share one thing here.
Hanji, bilkul, sir.
Surat Municipal Corporation is started to reuse of the sewage water. And I tell you what is scenario right now. The water which is supplied by the Surat Municipal Corporation after the treatment have a much more demand compared to the water which is supplied by the Surat Municipal Corporation direct to the industry. Industry saying we will pay the money whatever is required for the reuse purpose, but you supply me the tertiary treated water, because industry is facing lot of problems due to the salt and other things. And in Surat right now we are reusing the 80 mld of the sewage water after the tertiary treatment, and industry is crying for the tertiary treatment. And every year the now Surat Municipal Corporation have a target to increase the at least 40 mld of the water in a year. So this is the scenario in industry right now, specifically in Gujarat, we can say.
I am from a water industry and I will endorse this. I sell more projects for sewage treatment and I make more profit in selling sewage treatment and recycling systems. Then I can make the profit in the normal water treatment plants. So from the industry perspective, if we have the right techniques for recycling, there is enough opportunities for everybody. Thank you, Professor. Yes, Chitraji.
Thank you. Thank you so much, sir. Thank you, Professor K.D. Yadavji, and thank you, Anil Manocha, sir, for updating us and giving us so many knowledgeable points to ponder on as a citizen of India. And I wish that everybody has gained many things from these points and will take care of them in future also. So once again, wishing everyone a very happy Guru Purnima Parv. Take care of yourself, take care of your water resources, take care of your family, take care of your society. And with this, while saying thanks to both the dignitaries, both the guests, I'm just signing off from this webinar, and we'll meet soon at 6 p.m. as